Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 12th graders 2017, problem number 4. Let A be a unital ring in which is not a division ring, and such that every non-invertible element of A is idempotent. We wish to show two things. First, we have the following. Units of A plus A minus the units of A and minus 0 intersected with the set of units is empty, convoluted, but you will see in a moment. And part B, every element of A is idempotent. And to clarify some things, division ring means that every non-zero element has its inverse. So not being a division ring means that there is some non-zero element which does not have its inverse. Idempotent basically means that A squared equals A. So if we multiply A with A, we get A once again. It means to be idempotent. And moreover, here we have plus. You may wonder, what does it mean to add two sets? Well, set X plus set Y is the set of all elements of the form X plus Y, where X is in X and Y is in Y. Alright, so here are my hints for this problem. Let me put it right here. Perfect. Now, first hint for part A. Suppose that we have some unit of A, we have some A which is not a unit and which is not 0. Suppose to the contrary that U plus A is invertible. Then you can write that U plus A times some V equals 1 for V which is invertible element of A. Then show that AV equals 1 minus UV, so 1 minus UV should not be invertible. And use the assumption that if we take not invertible element and square it, we get this element once again to get a contradiction, to reach a contradiction. Part B is trickier. To show part B, we'll demonstrate something equivalent that, well, in fact, the only invertible element of A is 1. The only invertible element of A is 1. Suppose to the contrary that we have some other invertible element, U, and now use the fact that our ring is not division ring, so you can choose A which is not invertible and which is not 0. Show that 1 minus U is invertible, and then show that AUA is A 1 minus U, A is also A, and add these equations together to show that it is in fact impossible. Along the way, use the fact that A squared is A. So give this problem a try, and I will see you in just a minute. Alright, so let's start with part A. For part A, suppose to the contrary, let's suppose to the contrary that there are U, which is a unit, A, which is not a unit, and it is not 0, such that U plus A is a unit once again. We will show that it is impossible, so if we intersect elements of a form U plus A with a set of invertible elements, we get nothing. We get empty set. Well, since U is invertible, since U plus A is invertible, there is invertible or just any element V such that U plus A times V equals 1. Alright, but now let's take a look. This means that AV equals 1 minus UV. Alright, but now let's take a look. Notice that here we have element which is not invertible times some element which is invertible. Well, of course V is invertible because V times something equals 1. well-known fact that if we multiply element which is invertible with an element which is not, we get once again an element which is not invertible. This definitely is not invertible. So, by assumption, 1 minus uv, since it is not invertible, it's idempotent. So 1 minus uv squared equals 1 minus uv. And let's investigate this. This means that 1 minus uv plus uv equals 1 minus uv. Let's shuffle this equation a bit, and well, we will get what exactly? Ones cancel, minus uv minus 1 uv cancels, so we are left with uv equals uv. And now what I will do, I will take this equation, multiply on the left hand side by u inverse, multiply on the right hand side by v inverse. They exist by assumption. So I get v times u equals 1. So they are inverses of each other. Alright, so, but this means, of course, if I multiply by v inverse, once again, let's multiply by maybe u inverse. We get that v equals u inverse. But that leads to a problem, because let's get this line right here. Let's copy this line right here. And now we get the following. AV equals 1 minus UV, but what is UV? It's 1 minus U inverse. 1 minus 1 is 0. And now I will take this line and I will multiply by V inverse on both sides. So I get that A equals 0. And this is a contradiction because we have assumed right here that it is not. We get a contradiction. Clear contradiction. Which means, this means that, well, let's rewrite it, that units plus non-units intersected with units, well, in the end we get empty set, which closes part A. This closes part A. Part B, much more interesting. Maybe not much more, but more interesting. For part B, we will show that, well, this strong fact that the only invertible element is 1. Because, let's consider this. If this is true, then every element which is not 1 is idempotent, of course, and 1 itself is also idempotent. Then 1 squared equals 1, of course, and A squared equals A for A not equal 1 by assumption, which will conclude the proof. But we have some work to do. Again, let's suppose to the contrary. Suppose to the contrary that there is some unit which is invertible, but it is not equal 1. Now, since A is not a division ring, there is also element A which is not invertible and which is not 0. we'll use this very element. Just one. All right. So we have U, we have A. Now, let's take a look. First, notice that U can be written as 1 minus U, or maybe better. Maybe better, let's write it like that. 1 equals U plus 1 minus U. And now let's consider that. Notice that this element is invertible. This element is invertible as well. So this element right here, well, it must also be invertible or 0. Why is that, you may ask? Well, because if, let's explain this, if 1 minus U were in the ring but not invertible and not 0, then we immediately get a contradiction with A, with part A. We get contradiction with part A. Because then we have a unit, we have non-unit, and some of them is unit once again. We have excluded this possibility. So, but notice that we have assumed that 1 is not equal to U. We have assumed that 1 minus U is not 0, so it must be invertible. So 1 minus U is invertible. It's invertible. All right. So we have found two invertible elements, U and 1 minus U. And now, since A is not invertible, since U is invertible, and since 1 minus U is also invertible, we have the following. AU is not invertible. It's not invertible. And likewise, A1 minus U is also not invertible. Again, if we multiply element which is not invertible times something which is invertible, we get something which is not invertible. Easy to verify that. Now, since this is the case, AU squared equals AU, and A1 minus U squared equals A1 minus U, because by assumption, every non-invertible element is idempotent. So AU equals AU, and A1 minus U equals A1 minus U. And now notice the following. Since U is invertible, we can cancel this U on the right hand side. And since this is invertible, we can cancel this as well. And we get the following. AUA equals A, and A1 minus UA also equals A. Let's take these two equations and let's add them together. So we have AUA plus A1 minus UA should be equal A plus A. All right. AUA plus we have A squared minus AUA equals A plus A. Now this cancels with that, and we have A squared equals A plus A. But remember that A squared is also not invertible, so it is also idempotent. Since A is not invertible, by assumption, it's idempotent. So A squared equals A. So we get the following. A equals A plus A, and after subtracting A, we get this problematic equation, 0 equals A. But remember that it is contrary to our assumption, because if we go back, we have chosen A to be not invertible, but also not to be 1. So we get a contradiction. 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 Which means that in fact the only invertible element of our ring is 1. You may wonder, what about -1? Well, in our ring 1 equals -1. So 2 equals 0 in this ring. There are rings, right, like that. So we have demonstrated that the only invertible element is 1, so every element of A is idempotent. And this closes our proof of this very nice algebraic problem from ring theory this time. So yes, I hope that you've learned something new this time. Thank you very much for watching. I wish you a nice day, and I will see you next time. Goodbye.